Oogenesis is the process of egg cell development in females. It all starts in the ovaries, where primordial germ cells begin their journey. These cells undergo mitosis, creating oogonia, which are the early egg cells. As they grow, they enter a phase called meiosis, but pause before completing it. This pause can last for years, sometimes until puberty or even later. Once a month, during the menstrual cycle, one egg resumes meiosis and matures. If fertilization occurs, the egg completes meiosis, leading to a viable embryo. So, oogenesis is not just about making eggs. It's a complex, timed process.
So, let's dive into the multiplication phase of oogenesis, where the magic begins. This is when the primary oocytes undergo mitosis, creating more cells. It's like a cellular party, doubling up to prepare for future development. These cells are crucial for forming the eggs that will eventually be released. Each primary oocyte is surrounded by a layer of support cells, forming a follicle. This phase sets the stage for the next steps in egg maturation. It's fascinating how our bodies prepare for potential life, isn't it? Understanding this process helps us appreciate the complexity of reproduction.
So let's talk about the growth phase of oogenesis, shall we? This is where the magic begins, as primordial germ cells transform into primary oocytes. These oocytes are surrounded by a layer of supportive cells, forming what we call follicles. During this phase, the oocytes undergo a crucial growth spurt, accumulating nutrients and organelles. It's fascinating how they prepare for the future, getting ready for that big moment of ovulation. This growth phase can take years, sometimes even decades, before they're fully mature. So, next time you think about eggs, remember the incredible journey they go through.
So, let's talk about the maturation phase of oogenesis, the fascinating journey of egg development. This phase is crucial for producing healthy eggs, or oocytes, in the ovaries. It begins with the primary oocyte, which is arrested in prophase of meiosis-I. As puberty hits, these oocytes resume development, preparing for ovulation. During maturation, the oocyte grows and accumulates nutrients, essential for future fertilization. Follicular cells surround the ovocyte, forming a protective layer and supporting its growth. This phase is all about quality over quantity, ensuring only the best eggs are released. Once matured, the oocyte completes meiosis, ready for that big moment, fertilization. Understanding this process helps us appreciate the complexity of human reproduction.
Fertilization is a fascinating process that brings new life into the world. It all starts with the union of sperm and egg, a tiny miracle in itself. This meeting happens in the fallopian tube, where magic begins. Once fertilized, the egg travels to the uterus, ready to implant. This is where it all gets real, nestling into the uterine lining. If conditions are right, it will grow and develop into a baby. It's a delicate dance of biology, timing, and a bit of luck. So next time you think about life, remember this incredible journey. So, meiosis-I is a crucial step in cell division, right? It's where we see the magic of genetic diversity begin. First up, homologous chromosomes pair up and exchange bits of DNA. This process is called crossing over, and it's pretty fascinating. Next, the cell divides, separating those pairs into two new cells. Each of these cells now has half the number of chromosomes. But don't be fooled, they're still in a duplicated state. This sets the stage for Meiosis-II, where things get even more interesting. So, that's Meiosis-I in a nutshell. Pretty cool, huh?
So, let's talk about the completion of Meiosis-II. This is where things get really interesting. First, the two cells from Meiosis-I divide again. Each cell splits into two, resulting in 4 total cells. These cells are haploid, meaning they have half the number of chromosomes. It's like a genetic shuffle, creating diversity. And guess what? Each cell is unique. This is crucial for sexual reproduction. So, there you have it. Meiosis-II in a nutshell. It's all about creating variation for the next generation.